Examples of functions, introduction. So let's move on to looking at some examples of functions. Now, in the sections we've covered previously, we established that a function is a specific kind of relationship. A relation, if you will, between two sets. Remember, any set is just a collection of distinct objects. The most important thing to remember about functions is this. A function must assign exactly one element from what we call the codomain to each and every element in the domain. Think of it like this. You put something in, that's your input from the domain, and the function gives you something out, that's your output, which comes from the codomain. But for any single input, there can only be one output. No ambiguity allowed. What we're going to do in this section is really solidify this idea by working through several examples. We'll be using sets to define our domains and codomains, and then we'll see how elements move from the domain to the codomain through the function. We'll be very careful to check, with each example, that this one input, one output rule is always followed. If it isn't, then what we have isn't a function, it's just a relation. So, let's start building our understanding with some concrete examples. Example 1, a simple squaring function. So let's move on to our first concrete example of a function. As we discussed in the introduction, a function is a special type of relation, and it must have a clear rule assigning one, and only one, output for each input. Now let's consider a function we'll call f that simply squares a number. So, it takes a number and multiplies it by itself. We need to define what numbers we're allowed to put into the function, that's our domain. We'll call our domain A, and we're going to define it as the set containing the numbers 1, 2, and 3. Think of these as the possible inputs to our function. Next, we need to define the codomain, which is the set of possible outputs. We'll call this B, and it will contain the numbers 1, 4, and 9. Notice that these are the squares of the numbers in our domain. Now here's the rule for our function f. We write it as f of x equals x squared. That means, for any number x that we input, we multiply it by itself to get the output. Let's see how this works step by step. If we input 1, that is, if x equals 1, then f of 1 is 1 squared, which equals 1. So the input 1 maps to the output 1. Next, if we input 2, that is, if x equals 2, then f of 2 is 2 squared, which equals 4. So the input 2 maps to the output 4. Finally, if we input 3, that is, if x equals 3, then f of 3 is 3 squared, which equals 9. So the input 3 maps to the output 9. We can represent this entire function as a set of ordered pairs. We write it as 1 paired with 1, 2 paired with 4, and 3 paired with 9. Remember, the first number in each pair is the input from the domain, and the second number is the output from the codomain. Now look closely. Notice that each number in our domain, 1, 2, and 3, is paired with exactly one number in the codomain. This is the key property of a function. Because each input has only one output, we can confidently say that f is indeed a function. We'll build on this understanding in the next examples, and also look at some common pitfalls to avoid when identifying functions. Example 2, a function with a different codomain. So let's move on to our second example. As you recall from the previous slide, we were looking at how functions map elements from a domain to a codomain. Now, in this example, we're going to keep the domain the same, that is, the set containing the numbers 1, 2, and 3, but we're going to broaden our codomain, the set of possible outputs. So our new codomain, which we'll call B, will be the set containing the numbers from 0 up to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Notice it's a larger set than we had before. Now we'll define a function, let's call it g, and this function will take an input x and multiply it by 2, then add 1. So mathematically, we can write that as g of x equals 2 times x plus 1. Let's see how this function works with each element in our domain. First, if we input 1 into the function, so g of 1, we get 2 times 1 plus 1, which equals 3. Next, if we input 2, so g of 2, we get 2 times 2 plus 1, which equals 5. And finally, if we input 3, so g of 3, we get 2 times 3 plus 1, which equals 7. So we can represent this function as a set of ordered pairs. We have 1 paired with 3, 2 paired with 5, and 3 paired with 7. We write this as the set 1, 3, 2, 5, 3, 7. Remember, each input has exactly one output, which is a key characteristic of a function. Now look closely at the codomain B. We used the numbers 3, 5, and 7 as outputs, but we didn't use all the numbers from 0 to 9. This is perfectly fine. A function doesn't have to use every single element in the codomain. The codomain just defines the set of possible outputs. It's like having a toolbox. You don't need to use every tool in the box to complete a task, but it's good to know they're available if you need them. Keep this in mind, as it's a common point of confusion. We'll reinforce this idea on the next slide, where we discuss common mistakes students make when working with functions. Example 3. A function with a constant output. Let's move on to our third example. This one is a little different, and it's designed to really solidify your understanding of what defines a function. Here, we're going to define a function called h. We'll say that the domain, which is the set of all possible inputs, is A, and it consists of the elements B and C. So, A equals the set containing B and C. Now let's define the codomain B. This is the set of all possible outputs, and we'll set it to be the numbers 5, 6, 7, and 8. Here's the interesting part. We're going to define the function h such that for every element in the domain A, the output is always 5. In mathematical terms, we write this as h of x equals 5. For all x belonging to A, this means no matter what input we give from our domain, the function will always return 5. Let's map each element to confirm. H of A is equal to 5. H of B is equal to 5, and H of C is also equal to 5. We can represent this function as a set of ordered pairs. This would be the set containing the ordered pair, A, 5, B, 5, and C, 5. Now it's important to notice something here. All the elements in the domain, B and C, are mapping to the same element in the codomain, which is 5. Even though we aren't using all the elements in our codomain, we're not using 6, 7, or 8, this is still a perfectly valid function. Why? Because the key rule is that each input must have exactly one output. And in this case, each element in the domain has a single defined output, 5. Remember, as we'll discuss on the next slide, a function doesn't have to use every element in the codomain. The codomain just tells us what possible outputs there are. So, this constant function is a good example to keep in mind as we continue. Common mistakes. A very frequent error I see students make is believing that a function must use every single element within its codomain. That's not actually a requirement. Remember from our earlier examples, like with function g, we had a codomain with several numbers, but the function only outputted a few of them. The codomain simply defines the set of possible outputs. Think of it as a menu of options. The function then picks from that menu. It doesn't have to order everything on the menu. So, a function only needs to assign one output to each input, and that output must be an element that exists within the codomain. It's perfectly fine if some elements of the codomain are never used as outputs. Now, let's talk about another critical mistake. A function cannot assign more than one output to the same input. If you define a relation where, for example, f of 1 equals 2 and f of 1 also equals 3, that is not a function. That violates the core rule that each input can only have exactly one output. If an input has multiple outputs, it's a relation, but it's not a function. Let's move on to slide 5, where we discuss some common mistakes students make when working with functions. Keep these 2 points in mind, and you'll avoid some of the most common pitfalls when identifying and working with functions. We'll reinforce these ideas as we move forward, so don't worry if it doesn't click instantly. Key takeaways. Remember when we talked about what makes a function special? It's all about this one-to-one mapping. For every input you put into the function, that's your domain, there can only be one single output that comes out. That's part of the codomain. If an input ever led to 2 different outputs, it wouldn't be a function. This is a really common misunderstanding, so listen carefully. Just because we define a codomain doesn't mean every single value in that codomain has to be the result of the function for some input. Think back to our example with the function g, where we had a codomain of numbers from 0 to 9, but the function only produced the numbers 3, 5, and 7. That was perfectly fine. The codomain just tells us the possible outputs, not the guaranteed ones. We saw this in action with all our examples. We took each input from the domain and its corresponding output from the codomain and wrote them as a pair, like 1, 1, or a 5. This set of ordered pairs is a really useful way to visualize and understand what the function is doing. Knowing what your inputs are and what possible outputs are is the first step to working with any function. It helps you determine if a relationship is a function, and it's essential when you start doing more complex calculations and problem solving. Let's recap everything we've covered in this section on examples of functions. This slide summarizes the key takeaways, so pay close attention. These are the things you really need to remember. So, those are the key takeaways. Make sure you understand these concepts, because we'll be building on them as we move forward. Are there any questions about any of these points before we continue?